Assalamualaikum and good morning and good day to you. I hope you still remember me. So my name is Dr. Faika Shazia Muhammad Saleh. So we meet again in the computer aided engineering drawing for the course of EMM3518. So today I'm going to continue from Dr. Zuhair lecture. So on this lecture, you're going to learn about the sectional views and the pictorial drawings. Okay, so the importance of the sectional views is there's three main purpose. First is to show the interior details. If there's too complex of the object or too complicated, where you having these too many hidden lines, so it's much easier or it's much clear to see the interior details. And second is to document how the multiple parts of the object are assembled or built. And thirdly is for your the dimensioning. So here you can see, right, on your left side, this is the green box given and shows this the orthographic projection principles, or you are having this 2D, the top and your front side. Okay, so the top you can see there's a two circles. Okay, there's hole inside. Okay, so the dashed line or the hidden lines are showing you what is going to be inside. But if you're having these section views where you cut it into half, okay, you will see, okay, there's no hidden line, right? So it shows you without this, there's two part here. Oh, sorry, I need to show you this, the arrow. Okay, here. So these cross lines or the cutting lines or the what is called the section lining. So it shows this there's a different materials. So these may be made from the steels. So this one doesn't have this section lining. Okay, so this shows you a holes inside of the object. So this can be easier to interpret or easier to be look when you have these section views. And sectional views is frequently replace one of the regular views. So here, for example, as I said, if you cut it into half, okay, so this will be your top views. So as I said, this the object is being cut by the saw. So this is where the line shows you the cutting plane line. But also at the end of this object, two sides of it, you will see an arrows. Okay, arrows. So this arrows is actually indicate the direction of the side. So means you will see your front views here. Okay, by seeing here, you will see this is your front views. What you're going to see. So these section views show you what you're going to be look like at the front. Okay, so this is the materials where there's a section lining, and there's two like a screw shapes in this object. There's two here. Right, so there's hole inside of this object. So a regular front views is replaced by a front view in the section. Okay, I hope you understand this. So the cutting plane lines, okay, this line, as you can see here, are used to show the location of the cutting planes lines. So there's many types of cutting plane lines. It can either be the thick center line, thick phantom line, or even broken visible lines, where you only can see at the end of the object, or you can see it at the end tip. Okay, it's outside of the object. So the C is used if the cutting plane line would hide important details in a drawing. Okay, here I already said about the direction of the arrows. So the direction of the arrows indicate the direction of sides. What is your views? So this object is being cut to half like this. So your views will be where this person is sit. So next on this cutting plane lines, okay, cutting plane lines can be omitted when it corresponds the center line of the part. Okay, here. So there's a cutting, and it is obvious where the cutting plane lies. So here, if there's an arrow, even here there's a cutting, you can cut it anywhere, it will be the same. The views so you're going to see will be the same because it's like a uniform. Either way you cut it, you will get the same views at in front, like that, as long as you cut it at the middle, maybe here and here. So that's why it doesn't show you the arrow, okay, for this part, okay, for your this right side of the figures. The section lining, sometimes referred to as cross hatching, and can serve as a double purpose. So as I said before about the section lining, first is where to indicate the surface that has been theoretically cut and make it stand out clearly, thus helping the observer to understand the shape of the object. It also to indicate the materials of the object. Okay, here is where is regular views, means without, when you don't even cut it. Okay, so this is your front views. You know this is the hidden line. You know there's a hole inside of this object. So when you have this cutting plane line, okay, without section lines. So without section line, okay, you will see regular lines, means there's no hidden lines because you already cut it to half, but you don't know which materials is it going to be the same things. So when you have these section lines, okay, this what I said, it's like 45 degrees, cut it to like, yeah, this line shapes, it shows you it have a different materials made of, so you can easily to understand what it looks like from these section views. So there will be a hole inside, and this will be a material of the object. The lines for the section lining, okay, so you need to take note on this, how to draw the section line. So it need to be thin, and it is usually drawn at angle of 45 degree. Okay, it need to be uniform. Okay, it can't be like irregular, or lines is too close, or the varying line is too wide, or line is too thick, lines short, or overrunning is out of the object or over the box. Okay, so it need to be very uniform, very thin, and the angles will be at 45 degree. So if the section lining are drawn at 45 degree, okay, with the horizontal will be parallel or perpendicular or nearly so to a prominent visible outline, the angle should be changed to the 30 or 60 degrees Celsius or some other angles. As you can see here, okay, so the lines, the shapes of the object is the same with the section line that you have known, as usually you draw will be 45 degrees Celsius, right? So if you have the object will be having the 45 degree Celsius, so the lines should not be parallel. Okay, it also cannot be perpendicular to this to your object. So you need to adjust your section lines into 30 or 60 or more, it's depend on you, but don't even try to do the perpendicular lines. Okay, so you can change to 30 or 60. That's I more prefer to you. So these symbols, okay, actually there's more symbols. It's not only like 45 degrees lines, but this is like generals one. If you want to show different densities of these materials, like if there's a holes and there's a one materials, so you can easily detect between these two lines. So that's why these lines is showing if the material is made from iron or it's generals. But for the other type of section linings, so there will be like a honeycomb or what, there's a like a wave, there's a dash line, there's a pattern. So this different pattern shows you different types of material you use. It can either be steel, it can either be sand, it can either be a rubber, so other else. Okay, it can be either concrete. So it's all, it depends actually. So you need to learn, or you can search which symbols is made of. Okay, if it made from plastic, you can use this section lining. If, okay, this one, if the section there are too thin for the effective section lining, such as if you're having a sheet metal, so there's packing or gaskets, so it can be shown without section lining. Okay, you can be drawn like just a simple cross section without shows a section lining. You can also fill it with the section lining, or you can just color it. So it is okay. If this section is too thin. So we go back here. So this will be your full section. So it means you cut to half. You cut fully. Okay, so this is the other examples where there's a object where it's cut to half. Okay, this is fully. So this will be called as full section. This will be your top, and this is your section views. What you see, what you are going to see. So front and your right side view for this full section. And this one, okay. Actually, I want to have this circle line. So you're going to have this circle line, right? Okay. This is just example. Just imagine that I'm actually drawing a circle, a uniform circle. So you are actually just cut to only a quarter part of this circle. So your front views. So your one is this what going to be your exterior. This will be your interior. Okay, remember a half section shows a 1/4 of the part, not 1/2. Okay, let's go to the other slide. Okay, here there is another example. Okay, the cutting plane cut halfway to the axis or the center of the object. Okay, it cuts until the center, and then it need to be a quarter of the object. So imagine it's going to be remove this part, showing this like an object. You cut it a quarter here. So this would be your direction side of section. If you can't see it clearly, so this part is being removed. Okay, so you need to remember how it looks of the cutting plane, right? The dash line and the long lines, and that's also showing you the arrows. Okay, if you having a quarter, so means showing you the only one arrow here. Okay, so you will see this one. It's going to be your exterior views. Okay, the hidden lines may be given in the unsectioned half. It is if necessary, if for the dimensioning. So here one is where you have been the object have been cutted. So use a center line to divide between the section and the unsectioned half of view. Okay. So there's another one. Okay, we have learned about the full section, the half section. So this one would be the offset section. So the offset section is where you cut it, you still cut it in a but it's not going to be in a straight line. It need to be bent. It's going to be bent. So you can see here in examples where the offset is cut into like a step here. This one is more depth and then become to the front of the object. It's cut. It's not in one line. In one uniform lines like this, like easier to cut, but it's like a step. So this mean is an offset section. Okay, we call it as offset section. So the cutting plane is offset from one another to include all the holes. So here they want to show you the whole, all the holes in the object. So this will be the other example for the offset. So this one also like a, okay, as you can see, it's not a straight line. So it's going to be having a bend like a step. But it also shows you the arrow where you to show you which side you are going to see, where is your front views, and this is the plane cutting lines. So this is going to be your top. It's going to be your top views. This is your front views. Okay, so this is what you're going to see. So next, we are entering the pictorial drawings. Wait a minute. Okay, what is exactly the pictorial drawings? It's actually more to where you can see on a 3D. Okay, if you are learning on orthographics, it will be on. It's actually more to on 2D. While for the pictorials, is where you can see more 3D views. Okay, it can be. I mean, you can draw these pictorial drawings into three types. Okay, it can be either be in an isometric, oblique, or perspective. So actually pictorial drawings, yes, it's provide you a 3D image, but it actually helps you to understand the shape of an object, and also a way to assist you to interpret a drawing more easily. So when you see a 3D, it's much more easier to understand how it's gonna look like. Okay, so it can be either be isometric, as I said, oblique, and perspective. So here will be the examples of these three types. There's the oblique. So you have these front views, and the isometric, you have these three axes. This is like a main, and there's a perspective where you have this point dot. Okay, remember, right? In perspective, your teacher is asking you to draw in school. Your teacher are asking you to draw pemandangan, a views, a scenery. So I will always try. Simple thing to draw is like a paddy fields, okay, or there's a gunung, there's a mountains. So you need to have a perspective where your point, right? Your teacher, right? You're having a horizontal line, and there's a point where you're going to look far away. There's a point beda jauh tu, it's far away, you can't see. So it shows you. So we gantikan dia sebagai as a point, because it's far too far away, can't see, so we change it to a point. It's like that's what I said, this for example for perspective. So actually for perspective is more to architectural drawing. So if you want to draw a scenery, or you want to draw I mean a buildings, so it's much prefer you to have a perspective. So remember, you have 3 types of these pictorials. Okay, first we are entering about the isometric first. So it's an isometric pictorial drawing for which the angle between the axes equals to 120 degrees, and the scale used is a full scales. So actually the isometric is most common one to draw for 3D, because it have a, even I say it's isometric means it have a equal, right, equal measurements. So what it means by that, they are having a equals of 120 degrees is here. So you can see right here in the figures, if a whole circle you're going to have like 360. So there's a x-axis, y-axis, or z-axis, okay, for sure. So each axis, the difference between axes will having 120 degree Celsius. So you need to have this point with this 3 axes with having of 120 degrees. So even if you are showing, okay, you can see there's 4 types or 4 ways to create different views of the isometric axis. But as long you need to draw when you have a point with 3 axes. So even in a regular isometric, this is the point. This for the reverse isometric, so this will be having a point. So for the long axis, so as long you need to know to mark it, okay, where's your point of view. So you need to start with a point with having a 3 axis, where, and also the the axis, the degrees between the axes should be around 120 degrees Celsius. So here the isometric axis can be positioned in a number of ways to create different views of the same object, and then also the regular isometric is the most common type. For the isometric drawings, the true length distance can only measured along isometric lines. That is line that is run parallel to any of the isometric axis. So here, okay, your axis, you are having 3 axes, right? And so if you're referring to these figures, see, this will be your isometric axis. So you're going to have 3. Okay, remember? Betul. 3 axes. So this plane, as you can see here, okay, there's a steep right for this plane. So this plane is a non-isometric line because it doesn't even follow the axis that you are having here. Okay, sekarang bentuk your shape of axis is like this, but the plane is like so steep. Okay, like here. I'm going to change the line. So this is your axis. So it's not following these 3 axes. Your 3 axes of isometric axis. Okay. So this will be this going to have a non-isometric lines, while the others, if you're having a same parallel or same axis of the isometric, you call the isometric lines. Okay, I hope you all understand here, okay? For the isometric drawings, the hidden lines are omitted, okay? Unless absolutely necessary to describe the object. So it's more preferable for the isometric to have the hidden line shows. But if you it's not necessary, yes, you can exclude it, but it's necessary to have this hidden lines. And it also shows in this isometric drawings, it shows you this center line. So you need to mostly it's going to it will shows you the center line. The center lines is for you to draw at the circles here. So this is a example center line there. So center lines is for dimensionings. Okay, for the dimensioning is for the production purpose. Mostly it will be put in a ANSI standards. ANSI, you know, right? The American I can't remember. American National Standards Institute punya standards, mostly in the inches, right? Before you have learned about this. If we are learning is more on the metric SI units. So if you're on the production purpose, they're mostly going to put in the ANSI standards, and the dimension lines, extension lines, and lines are dimension short lies in the same plane. So if you're having this object, all the lines that need to be at the same plane. Okay. And also you need to note that all dimensions should be unidirectional, reading from the bottom outwards and the outside of the views. So all the dimensions is put it at the outside of the object. So it also need to be unidirectional. As you drag it, okay, if you want to know this section, okay, you can't just put here. So you need to be outside. You need to outside of the object, and it need to be a unidirectional, same as where you wanted to know for the dimensions. So this is for the height of the holes until this point of center. So here is around maybe 20 inch, 15. Okay, this is the diameter. Okay, this symbol shows you diameter. So this is going to be the length. So it need to be unidirectional and outside of the views. Wait. Okay, let's go to the other side. So in constructing an isometric drawing, so you will be using a boxing in method. I think you have learned how the box work. Okay, there's upper side, there's a front side, right side. Okay, there's the bottom. So it will based on this boxing method. First step, so this going to shows you how step by step how you are going to draw these isometric drawings. First of all, you need to have these three axes. Okay, XYZ. You need to remember that it's like XYZ. You have three axes, and then you are going to have one plane from the front views, and then there's a top, and there's your side. So from there you can put more on details inside of this box. Okay, you have plane, right? Okay, I hope you understand what I said. First, having this is like, it's just for your review, a brief understanding about the isometric and how you're going to draw. Okay, later maybe you're going to learn about it. So for the isometric, you're going to have these three axes, and then you're going to have a box shape, as you need to have, like, if there's a box shape, means you have a front views, there's top views, there's a side views. So from these box shapes, so later you can put more details in this box. more and more details step by step. Then you can delete all the unwanted line. Okay, then what if you have non-isometric lines? So what are you going to do? So here shows you this blue plane, this blue color on the, okay, this shows you this blue. The blue part is the non-isometric lines. So this showing you this the top views. This is going to be your left, your side views, and this will be your front views. So you need to remember that true length distance can be only measured for the isometric lines. So for the non-isometric lines, it's not a true length, because even in the top views, you see, right, it's not the true length, because the true length, because it's slanted around 45 degrees Celsius, so it should be more than what you can see from the top views. For what I mean is the length, okay, because if you see on the top views, it's much more shorter, but if you see on the front views, it is a true length. Okay, so take note on that. So what if you have a curve? So you will do the offset coordinated method. So here shows you the step by step how to do a curve. So this is an offset coordinates method, where you need to be uniform, thick, very uniform from the front views and the left on your side, and then you need to mark it, and then you need to do like tangent something. I think you're going to learn more details, but remember, if you have a curve, you need to use this offset coordinate methods. So here's an example how to draw the isometrics. I hope you already know. Okay, this is going to be your top, this front, this is going to be your sides. This is step by step. I think this one has been shown at previous slides. So this also shows this offset method, and this one also shows you how to draw the offset, because you want to make this curve one. Okay, just go through, look how they do it. Later we can learn step by step on the manual or even in the AutoCAD. Okay, second for the 3D views is the oblique drawings. So this is oblique drawings, where you are having it's quite the simplest method for you to understand of the 3D views, because in which that a form of pictorial drawing in which you have these natural views is treated as the front views and is placed parallel to the plane of the projection. What it means by that is that you are having this your front view as a main view, as your main view. So you need to put your main view here. Do you understand? So the surface of front views, it need to be directly in front of the in front of the viewer. It's you. So you need to see your front view on this drawing, for this oblique drawing. So the front views need to be menghadap you. You are seeing this side. This front views is in front of you. Okay. So this one shows you different angles of the oblique drawings. If you can see here, it can either be like 60, 45 degrees, 30 degrees Celsius. It can be reversed, but need to make sure that the in front view is directly in front of you. Okay, so the typical oblique drawings angles are around 30 degrees Celsius. Okay, here showing you this is the 30 degrees Celsius. It can be either be 45 or 60 degrees Celsius. So this one is going to be I mean a typical or generally draw for this oblique type. And then there's three basic types of an oblique drawings. It can be either be cavalier, where it shows you the full length, full scales, and then there's will be cabinets. I mean I mean the length of the object is cut it into half scales, because sometimes it's not realistic to see the object in the full length. So the cabinets, it shows you more realistic views after being cut, because it's drawn to be like 45 degrees Celsius, right? So it can't be to be, if you see on a full scale, sometimes look it's not awkward, I mean like macam tak padan je, macam kelakar je. So that's why you need cabinet try to fix the views for the viewers, I mean for like us. And then yes, the words is much more, it's like sometimes appear too thick or distorted. Okay, distorted. So the cabinets is, that's why it's the length is cut into half. And there's also a generals where general oblique, where you have this full scale. Sometimes it can be either half and full scales, drawn anywhere from full to half lengths along the resting axis. So it depends on you. It can either be half or it's between half to full length. So you need to remember these three types of obliques: cavalier, cabinets, and generals. So for the oblique drawing, the object face, okay, the object where you see at the in front views, front section views, okay. So it need to be the complex features. You need to be having these complex features, or need to be having the widest space, the widest views. So as you can see on these figures, okay, so you can't having this, okay, this circle shape at your side. So you need to be facing your views. You need to be at the in front. So it need to be parallel to frontal plane. So this is more better to have a good oblique drawing. Okay. And also for this one, so they having a longest or more widest is need to be facing your side. It can't be on your right side. You need to be on the in front views. Okay, you need to remember the complex features or even the widest, you need to be at your front views. So you need to remember these first rules. Okay, for these oblique drawings, okay, the dimension, okay, before we are learning about the dimension of the what already forgot about the isometrics, right? You need to put the dimension is outside, and it need to be unidirectional with the oblique drawings. But for unidirectional for the isometric, for the isometric object. But for the oblique drawings, the dimensions is lie in the plane of the surface. So what I mean is the surface is your front views, to which they apply, and unidirectional text placement is used. So it's the same. It need to be unidirectional, but it's lie on your surface, your front view. Okay, here is your main part. Okay, you are having the size of your diameters around 1 inch. So, and then there's a center to center of the circles is around 1.25. So all the dimensions you need to put outside of the surface, but uh, you need to it's all depends all based on this surface. Okay, remember. Okay, this is how you going to draw the oblique drawings. So this shows you step by step how to draw. So here you are having the object. You are given an object. So first of all, you need to choose which are your surface. So as I said, you need to be the most complex, where you're having circles or irregular textures. Okay, it need to be your front face, your surface views. So this is going to be your front view. This is going to be your step 1, and then you need to know what is your degrees. So this one is sketch depth contraction line at 30 to 45 degrees, and then estimate the depth along the sketch lines. And then the third, where you draw a line between each depth mark to create the back edge. And then fourth is the last step. Okay, so go through one by one how it draws, so you can actually visualize in your mind how it's going to look. So last types of the pictorials is the perspective. Okay, I hope you're still with me. For the perspective drawing, okay, the pictorial drawings is used to represent 3D forms on a 2D media. So in a manner closest to how we perceive the object with our eyes. So how it looks going to have to looks like. So mostly you're going to have a vanishing point, VP. Okay, you need to have a point. You need to have this horizon line. You need to also having a ground line. Vanishing point, horizon line, and ground line. So the perspective views is where you are as a human. You are for sure you are human. You as yourself looking at this point of view. Okay, this point of view, or you are in camera. So what you're going to see? What is the projected image that you're going to see? So the same line of your eyes is going to be your horizontal lines. Okay, so it's just like the basic how you're going to see. Okay, if you are for the figures below shows you there's a road, and there's also like tiang electric, right? So on your right side is where the orthographic profile views, I mean in 2D, how we going to look like. So your eyes is the same as your eyes level will be same as your horizon line. And then what you're going to see, you need to have a ground line where you stand off, and then there's an object like this what I call tiang electric and also your point, vanishing point of the roads, or even for the tiang electric pole. Okay, electric pole, sorry, I hope you understand. Okay, tiang electric is electric pole, for you not understand, for you who do not understand. Okay, here again about this perspective drawings. Okay, you need to remember it is one of the best type of drawing lah. For you to provide a pictorial representation of an object, or even for the scenery, because it produces an image of an object in 3 dimension. Okay, where it have a similar to what the human eyes see. So what we're going to see is like is how the perspective drawing going to show you, because it's like we are using our based on our eye views. So for this view of the object can be dramatically changed by moving the vanishing point along the horizon line. So as you can see for the figure below, okay, there's three types, right? So here the VP is going to the right side. So all the objects is going to, based on the VP, is going to your left side. While at the B, for the B figures, the VP is at the middle, okay, it's just a regular one, standard one. And for the C's, where the VPs are going to change into your left side. So this one going to your right side, this is going to just center, this one going to your left side. So what is your views going to see? The points of the right center will reveal details about the right side of the object, while points to the left or center will reveal details about the left side. Okay. Go to the next slides. Okay, as I said that the human's eye view is the most commonly used for sketching everyday object. So the positions of the view has a dramatic effect on the representation of your drawing. So this is going to have a different types of views. If this is going to have a bird's eye views, this will be your your eyes views, because the height is between 0 to 6 inches. This is a ground eyes views. If you're seeing to from the top to below, and then there's a worm eye view. So there's different views you're going to see. So it all depends on your VP. So make sure your VP need to be on your horizontal line, okay? It can't be, VP can't be in the ground line, okay? So different types of eyes views. And then the perspective views drawing can be having 1, 2 or more or 3 points perspective. So it can either be having 1 VP, can either be 2 VP, VP right, VP left, and then this is 2-point perspective. We are having the 3. This shows you 3-point perspective. So the there's 4 variables to consider in perspective view drawings. One is the distance of an object from the picture plane, and then the position of the station points, and also the position of the ground line. And the fourth is the number of the vanishing points. So this is an example of the perspective drawings. As I say, it's much more it's much more on the architectural drawings, but it also can be shown for the, if you want to represent of an object, okay, or you're having a furniture industry, or you're having you're having this mechanical device. But it all depends on your eyes views. Okay, I think that's all for this lecture. So I'm going to continue later for the next lecture. So I hope you all understand about this pictorial drawings, and also about the sectional views. Okay, thank you.